Hi friends, welcome to the fourth lesson. This time we're drawing the free body diagram. The first thing you want to do when you are asked to draw a free body diagram is to smile. Make sure you have this big smile on your face because you are about to collect marks, free marks, okay? And then you come back. You look at or you read the statement carefully. A force of 30 Newton is applied to a box, so we know there's an applied force, moving it to the right at a constant velocity along a rough surface. Rough surface, we know there's frictional force. So we know there's applied force, we know there's frictional force. They said along a rough surface, again, the surface part tells us there's a normal force. Beautiful. Because it's an object, it occupies space. We know there is Fg, there must be weight. Any object that occupies space, that has mass, that must have weight, it must have Fg. So you've identified your four forces. You just go to the diagram and label them. The first force that you don't want to miss, even if you are confused, is the gravitational force, because that one, it doesn't matter what object we're talking about, it must have Fg. Another force that you can't miss, if an object is on a surface or is along a surface, the normal force, remember the normal force is perpendicular to the surface, right? So I'll just go ahead and draw it just over the box. Doesn't really matter where you put it as long as it's vertical like that and it's perpendicular to the surface. We have, those are our vertical forces. What else do we have? We are told this thing is moving to the right, or the force applied is going to the right. So let's go and put that force. We have our guy there, force applied equals to 30 there. Beautiful. There is frictional force because the surface is rough. Where is the frictional force acting, or which direction? It's going to oppose the motion. Since we are going to the right, the frictional force will go to the left. All right, kinetic friction. Now, I want you to pay attention. Okay? I want to draw your attention to this. The arrows, the sizes of my arrows are almost equal. Well, let's just assume they're equal. I'm talking about the horizontal ones, the length is equal. The vertical ones, we have equal length as well. That's because the forces are balancing each other. We have got constant velocity, meaning there's no acceleration. So the forces, the opposite forces are balancing each other. They will be equal in length. Okay? Now, what you want to do, you want to make a dot. Now, this is the free body diagram. This was not a free body diagram. Free body diagram, you make a dot. And you will just take these forces as you see them. The normal force there. Put it there. Allow it to act on that point. There is the normal force. The gravitational force, or the weight, or the Fg. The applied force. And finally, the frictional force. That is your free body diagram. And if, okay, let me give you also this hint. Normally, if the question is 3 marks, it means the forces are going to be 3. If it's 4 marks, you're going to have 4 forces. If it's 5, you are expecting 5 forces. So this question of ours, it was going to be 4 marks. That's what they do normally. Okay? So that's another thing that can tell you if you have all your forces drawn. I hope you understood everything. If you don't, feel free to ask in the comment section. I'm going to put effort to answering your stuff the best way I can. All right? Thank you very much for sticking with me throughout. We still have one more lesson, and we're going to be looking at inclined surfaces. Please go on, start from lesson 1, come down with it because they are building, okay, We build from lesson 1 all the way to lesson 5. So please go start there, watch every episode. Otherwise, I'll see you in the next lesson. I can send you over. Amen.